right, so here we are in chapter 5. So this is 5.2. And I start with this little picture. This is like a little bucket that's got some marbles in it. It's got like 8 blue ones and 2 yellow ones. And what if I'm running the experiment and I do it without replacement? Okay, well, so I want to get like 0 blue ones. Okay, well, if I want to get 0 blue ones, that means I pick out a yellow one. Ooh, yellow. And then I drop it on the floor because it says without replacement. And then I pick out another yellow one. So basically I got 2 yellow ones. Okay, well, there was a, make sure I'm doing this right. Oh, this is backwards of how I've got it. Backwards of how I got it in the notes. Okay, so anyway, I picked out 1 yellow one, put it on the floor, picked out another yellow one. So there was an 8 out of 10 chance for me to get that first yellow one, and a 7 out of 9 chance of getting that second one because of the one less thing. 1 blue one. Well, I could get a blue one and then a yellow one, or I could get a yellow one and then a blue one. Either way, you're not going to be able to tell the difference because I'm standing there with 1 yellow one and 1 blue one in my hand. So if I get a blue one and then a yellow one, it was 2 out of 10 on the blue. Now there's 9 marbles, but 8 of them are yellow because I took out a blue one the first time. But that's not the only way to get 1 blue one. It could be I get the yellow one first, so that'd be 8 out of 10. Now, the denominator's 9. Okay, but there's still 2 blue ones in there because I haven't taken one yet. Or it could be, now, I get 2 blue ones. Well, that means I get a blue one on the first try, and then I get a blue one on the second try, using that one last thing. Okay, so I'm just going to multiply these out. This is 56 out of 90. This is 16 out of 90 and 16 out of 90, so that's 32 out of 90. And this is 2 out of 90. Now, ordinarily, you're really supposed to reduce all those fractions, but I just left them the way they are because I just want to point out 56 plus 32, that's like 88, plus another 2. This is 90 90ths. Okay, 56 90ths plus 32 90ths plus 2 90ths is 90 90ths. So that's 100%. I've just covered every possible thing because it added up to 1. All right, now I have made up this little chart to summarize what I just figured out. Okay, X, well, that's the number of blue ones. Okay, if I really love blue way more than yellow, then I think getting a blue one out is a success. All right, so getting 0 blue ones out means I've had 0 successes, 1 success, or 2 successes, because they like to call this column the number of successes. Okay, and the probability of that. Well, if I go ahead and divide this out, 56 divided by 90, that is 0.622. That's where I got that number from. All right, and 32 divided by 90, that is 0.356. And 2 divided by 90, 0.022. And we already know if you add this all up, this adds up to 1.00. It adds up to 100%. Okay, which makes perfect sense. All right, that's 100% of the things that could happen to me. There's no like me getting 3 of them out of there. It shouldn't come out to be more than 100%. So those are the things that can happen to me, and it turns out that covers 100% of stuff. All right, now those 2 columns I get. Okay, that came from this. And usually when someone gives you one of these sorts of problems, they just give you the first 2 columns, and you're supposed to work from there. All right, so now I'm in my 3rd column, XPX. Well, okay, what that says is to take these columns and multiply them times each other. So 6 times 0.622, 0 times 0.622 is 0. 1 times 0.356 is 0.356. And 2 times 0.022 is 0.044. And if I add these up, okay, that'll turn out to be 0.4. That number 0.4, what is that? I mean, I can do the work, but what's it for? And they tell you, well, that's the mean. What does that even mean, the mean? Okay, what it means is that we had 90 of us, and we all have these little buckets in front of us. And every single one of us just ran one of these experiments. And then I went around the classroom and said, okay, how many you got? How many you got? And everybody's telling me how many blues they got. A whole bunch of people will be saying, I got 0. Oh, I got 0. Well, I got 1. I got 0. I got 0. I got 0. Well, I got 2. I got 1. Okay, there'd be a whole bunch of people saying 0. But some people are saying 1. And a couple of people would have said 2. So if I had 90 numbers right here, because I ran the experiment 90 times, and I wrote these down like this, and then I put them in, I just put them into my calculator under one variable stats. I put them in list 1, and I found out the mean of these numbers, that mean would be 0.4. Okay, this is a way of calculating what the mean of these numbers would have been. So I'm putting a mu right there, mu for mean. Okay, the mean is 0.4. So nobody is holding 0.4 of a blue marble, but on the average, if you look at all of us together, the average number of blue marbles any of us is holding is 0.4. That's what that means. All right, now the next column. Okay, x, well, that's my success column. 0 minus mu, that's my mean, squared, times p of x, that's the second column right there, 0.622. Okay, so I go 0 minus 0.4, which is negative 0.4, but then I square it, and when you square a negative number, every single one of these, you square a negative number, you're going to come out with positive. So there shouldn't be any negatives in that column. Anyway, so 0.4 times 0.4 is like 0.16, and then I multiply it by 0.622, and this is 0.09952. Then I do the same thing here, 1 minus 0.4 squared times 0.356. So 0.6 squared, 0.36, times 0.356, 0.12816. It's less sloppy in the notes. All right, and 2 minus 0.4 is 1.6 squared, and then multiply times 0.022. Okay, the notes are not correct here. All right, this is so, it's so much my habit. Just, oh, I need to grab a quick number with some decimals in it, and I suddenly end up in this column. Okay, I grab a number out of here and put it there, which you're not supposed to do. Make sure to drag yourself all the way back and put these numbers in to multiply by, which is what went wrong in the notes. But anyway, if you do it right, 1.6 squared times 0.022, you should get 0.05632. All right, I've done that calculation. And if I add all those up, 0.09952 plus 0.12816 plus 0.05632, it should come out as 0.284. All right, fair enough. That's the variance. Variance, archaic term, not used for anything, but there it is. That's the variance. And the one that I do care about is the standard deviation, which I get by taking the square root. 0.533. Okay, so I followed the procedure. All right, that's an awful lot of procedure. I followed the whole procedure, and I got that the mean is 0.4 and the standard deviation is 0.533. What that means is if I had written out this whole list of everybody in the whole classroom running the experiment and then did the one variable stats on it, not only would I get that the mean was 0.4, but I would get that the standard deviation was 0.533. Okay, and that's what's happening with these charts. You're just supposed to follow all the procedures, make sure to squeak all the way back to the P of X column to get this number. Okay, and you do these calculations. All right, now then there's like 4 homework problems on that, but luckily 2 of the homework problems are trick questions and you don't have to do them. Like this, okay? This right here is a trick question. Because if I add these up, that's 0.73. 0.73, I have not accounted for 100% of what's happening. Okay, maybe there's a 4 down here in the success column that they forgot to write on there. Okay, maybe there's a 4 and a 5 and a 6. I got no idea. I can't do this problem. You didn't even finish filling in this little chart. This little chart is called a probability distribution, and it's a lot like the frequency distribution. And where they come from, here I actually had a real-life example of where one could come from, but I could make them up off the top of my head. As long as that's a list of numbers starting with 0, 0, 1, 2, 3, following that pattern, and this column adds up to 100%. It counts as a probability distribution no matter where the numbers came from. Okay, and if it adds up to 100, then I can do this xpx and x minus mu squared px columns. If it doesn't, I get to write. Not a probability distribution. I get to move on to the next problem now.